Good evening, class.
Good evening.
Hopefully everybody can hear me. Good. Glad to hear it, Aaron. All right. Well, this is week 3 of our 5-week time together in this particular course. This evening, we're going to be talking about value stream mapping, and in particular, the future state elements of that process. So hopefully everybody had a good week and are ready to start into the third week, the midpoint in the course. There, basically, the text talks about 8 steps to lean improvement. The first of which is common with almost any operational or management system being put in place, you have to have a commitment to the process that you're trying to implement. That commitment comes from both leadership and from the masses and from the workforce. There has to be a commitment to learn and to implement any new processes, and that's the case with Lean as well. Choosing to use value stream mapping. We talked about that in week 2, and we talked about learning about the whole concept of Lean as a business process, and then mapping the current state. And when we map the current state, we basically are identifying where the organization is currently. So, in the case of your problems, you mapped out the current situation at your target customer with the intent of trying to figure out how they were doing things in the situation where they were currently having the issues that you had identified. Then as we move into this week and into the next part of the phase of the process, we start talking about identifying lean metrics, or those measurements that we can use in the current process to measure improvements in the process as we move into what we hope to be the future state. Mapping the future state basically is the concept of taking the current state, looking at the issue or the problem that you've identified, trying to find out in your research where the issues are coming from in the process that are causing you to have the problems that you've identified in the current state, and then how you can adapt or modify that current state in a future state to eliminate the waste and the process issues that you have identified in your research. To do that, you have to understand the customer and the customer's demand. Here we mean the demand from their customers and or their service, the customers for their service or product, and understanding how their customers see the process and see the future. The goal being to map that future state to resolve the issue that you've identified, but also to ensure that you satisfy the customer base. And implementing of continuous flow, one of the things we look at in both the current and future state is the flow of raw material or service through the operation, and trying to map out that so that we can maintain a continuous flow and eliminate bottlenecks or areas where the process slows down due to inefficiencies. And in so doing, level out the workload so that you don't have surges or gaps or unbalanced performance in the operation. All of that's done as we work in the area of moving from a current state to a future state. Next week, we'll be talking about Kaizen planning. Another term would be operational planning, and then the implementation of the Kaizen or operational plans as it relates to improving the process. So those will be the macro topics that we'll be talking about over the next 2 weeks. So when we say identify lean metrics, what would be some metrics that your organizations that you work in right now use to measure performance?
One that we use in supply is pretty much kind of like turnaround time, which is the time from which the customer orders a part based on priority. How fast did that part get pulled from the warehouse and delivered to the customer?
Okay.
So they look at that. They look at that standard, and the MatchCom has a certain standard. It's usually, well, right now it's at 1, so it's like it should no more than 24 hours, depending on what the priority is to make that part get to the customer.
Okay, and then they do is they track every order to see whether or not they're able to pull it and fill it within 24 hours. Okay.
Yes, and then they look at trends throughout the year.
All right, and if they start to see that extending, then they go looking to find out what's going on in the process, whether they don't have the product ready for immediate shipment or lack of personnel or whatever, right?
Yes, sir. That's when kind of like quality assurance gets involved and they start inspecting the processes. And that's when all that stuff gets reported up to the commander.
Okay, good. Anyone else have a metrics that you can think of that your company measures on a regular basis to measure performance?
On-time delivery is measured at our company.
Okay, and how do they define on-time delivery? I mean, what's the measurement for? How do they do it?
As long as we meet the contract deadline, if we supply the customer with X amount of products by a certain date, then we're on time. But if we miss that contract date and we haven't supplied them with the number of products that we're supposed to, then we've missed the delivery date and time.
Okay, so in your contract, you have lead times as far as how quickly you're supposed to fill the order?
6 to 1. Yes.
Okay, good. Anyone else? Okay, well, both of these are common indicators, and they're very effective. There's depending on your industry, depending on your operations, there can be many process metrics. These 14 are just a small list of some that companies often use. CT, which is the cycle time, the time it takes to complete the process from beginning to end. If you're manufacturing a product, that could be from the point that you receive the work order and start production to when you complete it. Changeover time is another indication. If you're in a operation where there's tooling or equipment that needs to be modified or changed to deliver product, how long that changeover takes. For example, in an injection molding operation, when you move from one component or part to another part, you have to take the injection mold out of the press and set a new mold in the press, and then you have to make sure that your process is in balance by producing parts to standard and so forth. The time it takes to do that, depending on the company and the size of the machine, could be anywhere from hours to days. Lead time, meaning how long does it take you to fill the order from the time you receive it until the customer receives it. Uptime is one that is often measured in manufacturing. It's a indicator where we are looking to see how much is the equipment up and producing product. A lot of times, due to maintenance issues, due to supply issues, personnel, we can end up with lines sitting idle. So uptime is a measurement that we use often to ensure that the machinery is producing product at the rates they're supposed to do. A lot of times companies will measure throughput and say that the machines are operating effectively, but throughput doesn't tell you is the fact that you would shut down for 6 hours. It just says that while you were running the machine, you were producing the rate at which you were supposed to produce it. Uptime measures to make sure that the machines are actually operating efficiently and the amount of hours they're supposed to be producing. Production batch sizes has to do with a concept. If you're running a batch manufacturing process, if they set a standard that says, okay, a batch you're gonna produce 500 pieces per batch, and you only produce 450, then you would be below standard. Number of operators. A lot of times companies will throw labor at a process to try and keep the rate up. And if all they're doing is tracking parts per hour or parts produced, that's not going to show that the reason they were able to maintain that rate was they added 4 people to the process, thereby adding cost indirectly to the process. So we often measure number of operators per shift. Pack time or trays, pallets for shipping, or pack size can be whether or not you're using the right shipping material and not using excessive material to produce a shipment. Working time is just looks at whether or not your employees are taking too much lax time or break time at the exposure, and thereby not running the amount of time that the process is designed to run. Scrap rates are pretty self-explanatory. That's throwing away too many bad parts. Tack time and process time we'll talk about a little bit more later on, but they are process-related measurements that determine effectiveness of the process. Value add time, planning non-value added time, and waste non-value added time are all measurements that allow you to vary whether or not you're actually producing the number of parts that you're specified when the process was bid for the pricing structure. So these are just some examples. There's hundreds of them out there, but each of these will provide a different look at a process and at effectiveness. And many times companies will use 3 or 4 of the ones you see here on the list for various comparisons to be able to determine whether or not a process or a manufacturing line is running effectively. So, looking at some of the most common ones that we see, one is lead time. So lead time is how long the whole process takes. So the lead time involves all of the facets of the process from the beginning to end, from the moment you started the activity, which could be raw materials, it could be ordering the parts, receiving the order from the customer, to transportation, supply time, process queue, wait time, inspection, shipping, billing, all of the process that takes you from the beginning to the end is what we mean when we talk about total lead time. And many companies will track that as a way of determining whether or not you're getting enough parts through the process effectively, and whether you're wasting time in the process. Process time is the time a unit or document is actually being worked from the first activity to the total completion. Some companies start at material entering the line through delivery. So in the case of process time, we're talking about the amount of time that the product is actually being value add or being worked. So if you have a wait time or a queue time in your process, that doesn't get included in the process time because you're not actually adding value to the product. So the process time in this example here would be the gathering data and creating the document. It would be considered process time. Moving product around the plant and waiting to work on the order is not process time. So it can be a very effective tool when you're trying to measure all your steps in your process and make sure that the process steps are working effectively. The drawback to it is that these dead times don't get paid attention to, and if they start growing, you can become unproductive just simply because you've got too much in the queue sitting here where you're not doing anything. Cycle time is how frequently an item or document is actually completed by the process steps. Also, the time it takes a person to go through all of his or her work elements before repeating them. So a cycle time is the entire amount of time that step takes. So in this case, it includes the wait time and the moving of the product around the facility. So it's everything you do in a process from beginning to end. And when you start repeating yourself, then you're at the beginning of the queue again, and the process starts all over again. So cycle time does allow you to determine whether or not you're using all of the moments that you've been given for that process. if in fact a process requires a wait time. And where you might see a wait time would be, for example, if you had a product that had to cure or had to dry before you could go on to the next step, then that wait time is part of the process, and you don't have any real way to get around it unless you can come up with some way to speed up that process. What companies will often do to avoid the lost time of a wait is they'll have multiple jobs going so that there's always a job starting immediately upon when the wait time is, so that you're always keep your people busy making product by just having multiple layers of production starts, so that the wait time uh, doesn't mean that the line is sitting there doing nothing. Any questions on those terms so far before I move on? Again, I'm trying to just cover the ones that you'll most commonly see in a manufacturing environment. Takt time is the measurement of customer demand. So it comes from the German word for meter, which establishes the pace or beat of the process. So takt time is the customer's demand rate for available time, and then available time. So you're dividing the customer's demand by available time to come up with the takt, which in this case, if we were looking at this model, you have 6 steps. In this third step, you've got a cycle time of 10 minutes. You've got these processes here that are process time. The takt, 2 parts, come off the line every 10 minutes. So that's what they mean by a takt. So when you take these times and you look at them in a production line, it's telling you that you're going to get 2 parts off the line every minute. So in this case, the math there is you have the part demand. The customer wants 5 per time cycle. 2 parts come off the line every 10 minutes. So 2 divided into 10 gives you the demand of 5. So this line its takt time of this production line is it's going to produce the 5 parts per time cycle, whatever. It doesn't tell us whether that's per hour or whatever. We'll assume in this case it's per hour. So it's 2 over 10, which then gives you 5 to be able to determine how many parts are going to come off the line. So if your customer wants to get 15 parts per hour, if this is an hourly rate, that would tell you you've got to have 3 production lines, because you're going to get 5 off each line. And so if you wanted 15, you'd have to have 3 lines. And so that's one of the things we use takt time for, is to help us decide throughput and whether or not we have enough production lines to meet the needs of the client. Okay, any questions on takt time? You'll hear this a lot from engineers, and this is a critical number if you're a manufacturing facility trying to keep up with a customer, especially if you have a process that can't make product fast enough. This is the formulation that we use to decide how many lines we're going to need to be able to meet the customer's demand. Okay, so we talked last week about mapping out the current condition of the process, and you all did, in your homework assignment, you mapped out the process for your client. You talked about where the process was currently. Then, as you are preparing to decide what you're going to do to improve the process or to fix the problem that you've identified, you then have to go and design a future state. So this is just an example of a potential process for current state in which a company is producing a product, and they're doing it in what we would call a lineal direction. So for example, this happens to be metal and welding. And so these steps are showing that they initially stamp out the metal parts, they weld the parts once, and then they have a second welding process, and then they have 2 assembly processes that complete the assembly and ship it to the client. And so what this table shows you is it shows you the time per cycle and how much they produce and the uptime for each of these steps. And then it tells you the cure time in between each process that the process is sitting there. So when you look across the bottom here, it takes 5 days from the time they get an order for them to start stamping the product. It only takes 1 second to stamp the amount of product it takes to fill that order. Then it sits for 6.5 days in their process. The next welding step takes 38 seconds. It sits for a day and a half waiting to get into the shop 2, where it takes 45 seconds. It then sits for 2.5 to 2.6 days waiting to get into assembly 1, which takes 61 seconds. And then it takes 2 days waiting in the queue to get into assembly 2, which takes about 40 seconds. And then all of that runs through and then to the shipping department, who then ships it. So what this is basically showing you is that the actual manufacturing process time it takes to make a single assembly is 184 seconds. So it's basically 3 or 4 minutes. But yet the manufacturing process, given all the time delays involved in their process, it takes 23.5 days to take the product through from beginning to end. So that would be an indication in most cases of a very ineffective process because it's 5 minutes worth of production time and 24 days worth of sitting waiting for this process to move through these individual shops. So this would be an example of a shipping and manufacturing situation that, while it may have been effective in the past, it would give them heartburn trying to compete in a modern environment. It takes, they show here, it takes 6.5 weeks for the product to get to the steel company, so that from their customer orders. So they fax it to the customer, and it takes 6 weeks to get the raw material. The forecast they're being given is about a 90-day forecast, and they get orders daily. And so that daily order waits 6 weeks before it gets down here to the production line to be able to move through as well. Okay? So first, we would want to, in that sample, we'd want to identify all the steps currently required to move the product from the order to delivery. And that's what that chart was showing, how it was moving through the flow. So that's what a current state would do, and that's what your coursework showed as you were developing that for your homework last week. We then challenge every step and ask why it's necessary. Would the customer think that the process is worth less if the step could not be if the step was left out? Many steps are only necessary because of the evolution of the process and the system. Workarounds, expectations, inconsistent training, previous decisions about assets and technology. So if we go back, those kind of decisions, for example, and we don't know this for sure based on the sample we have here, but let's say manufacturing decided, or the ownership decided they weren't going to invest in new equipment, new welding equipment, new stamping equipment, and therefore you had to run this lineal track, which is driving all this wasted tack time in the process. Or you may have had a situation where we didn't have enough people to work on these sections as simultaneously because the people had to be moved around to accomplish work. So they might move from the welding 1 over to welding 2 to produce that product because they can wait for a day and a half and use the people in both shops. So all of those of these type of issues often drive that kind of waste. And so what we do is we try, as I said, we try to identify why product is moving through the system or through the plant the way it is. We challenge every step. We do not assume that the step is necessary, and we don't assume that the step is productive. So we challenge it, and we do everything we can to ensure that the process needs that step. And we challenge it by looking at and saying, is this something the customer is willing to pay for? Or are we just doing this because of poor planning, poor training, poor technologies, antiquated technology, and that we need to improve the process. As we move in then and start talking about the future, we talk about what processes value prevents value from being flowing through to the customer. So we want to know what in the process is causing work or reaction that isn't driving success or value to the customer. And that can be things like process interruption. If you notice in that first model, we stop in between each phase. And the product sits in the queue waiting for the next shop to take it. Low first-time yield can be an issue based on when you first start up equipment in particular. High cost of poor quality, scrap rates, downtime and uptime percentages could be critical considerations when you're looking at going into that next or future state. Setups and frequent stoppages. Why are we stopping these products moving through the line in the case of several days for each one? Excessive inventory. Under this original plan, because of all these multi-day delays, you can imagine if it's only taking 61 seconds to make a part, and they're sitting around for 2 days, you can imagine how much production is sitting in inventory, a work in process in each of these steps, and that costs money and gives you the opportunity for failure. Bottlenecks, delays in waiting, parts not available when needed, wrong skills, wrong people, and unbalanced workload are all things that we look for as we're studying current state to try and figure out where we can make improvements as we move into a future state assessment. The kind of questions that we would ask ourselves as we're looking at the present or future present state, as we're trying to determine what we're going to do in a future state, is we'd ask ourselves such as, what is the customer's demand or tack time? So in the case of the sample, we were saying if the customer needed 15 per hour and we're only producing 5 off that line, then that says we either have got to figure out a way to speed up the line or we need 3 lines. But that's one of the questions we would ask as we're looking at future state. What is non-value add, and can we remove that or reduce that? So the things that we do in that original process, such as moving inventory between each of these stations and then sitting on it for multiple days, would be a question that we could ask ourselves as it relates to non-value add. Where can we work in parallel? So are all those stations, do they need those? They're right now set up in tandem, or they follow each other. The question becomes, can any of them be done at the same time? Where can we create continuous flow so that we don't have those delays in between? Where can we add to our supermarket pull system control process or upstream processing? So how do we change the process so we're pulling the product through the process instead of pushing it? And where can we establish workflow cycles or integrated events that allow us to improve the process by effectively controlling the process and eliminating the waste? So other questions is, what is the interval? How long does the process take in the optimum manner? And is it significantly improved over the current state? At what single point do we initially work via a schedule? So when do we, what can we do to lay out a schedule so that each of the points in the process are defined in a process or a schedule, and we're not wasting time in between? How well we create a visual management time frame, so a pitch. So how do we figure out a way to design the process so that you can look at it and you can look at the process and you can see that there's a constant flow and there's no waste? How do we respond to changes in demand? In the case of the original system, if the demand changes in midstream, we're left with all that work in process that's sitting there waiting for a home. Where can we capture knowledge in the process? Where's the point where we can collect data that helps us to know whether or not to improve or we need to improve? And what process improvements will be necessary for the value stream to flow as your future state. So as you're looking at that current state and that proposed future state, what are the improvements in the process you need to make to achieve that? And what that becomes is basically what we think of as a gap analysis. So if process A is your current and process B is your future, you look at it and you say, okay, what are the differences in between the two? And that becomes the gap. That becomes the things that we need to change or accomplish to be able to achieve that future state. And so that then becomes what we work toward in our projects and in our technology to achieve that future state, is by working to accomplish the gap or close the gap. Okay, and capturing improvement requires for flow. So we talk about quality, high quality, predictable process, effectively and guaranteed. So for us to be able to have an effective value stream improvement process, we must have a high quality control system that allows us to be predictable and to ensure that we are in fact making good product and staying in the process and not working outside the process. Uptime, to be successful in that future state, you've got to have your equipment healthy and running. It does you no good to have the equipment idle. That's non-productive time, and you're not getting the throughput you need to be successful. Equipment running on time, in good working order, producing product to specification in a timely and effective manner is critical to improvement of the process. Materials, the right amount of the right material when needed and where needed. So making sure that the raw materials show up at the line at the appointed time, just in time, and that it's the right material and that it is to specification and performs to standard. Otherwise, if you cannot do that, then you waste time shutting lines down to bring in the right material to inspect the product that you made with the wrong material. All of that leads to waste. And then people, the right numbers and the right skills. Companies must, in their future state analysis, they must define the skill sets that the employees need and how many of them they need, and then the system needs to track that you have people that are in place that are qualified and the numbers that are specified. So to have an effective improvement process, you must be tracking quality, uptime, material, and people, and ensuring that those four primary characteristics are properly measured and properly performing within the future state assessment, and when you move into that future state. As we apply lean concepts to this idea of value stream, we do so by calculating takt time to ensure that we understand the customer's requirements and how we're going to meet them. Decide on the finished goods strategy, first in, first out, FIFO. We have to decide that. Implementing continuous flow where possible. You don't want to have dead time and lull. Establishing a pull system rather than a push system. We want to be pulling the product and the material and the service through the organization, not pushing it through. Scheduling only one point. We need to be scheduling at the beginning of the process, and the process then needs to pull the product through the process based on that schedule. Defining appropriate intervals, and in that case, we want to make sure that the estimates and the projections that have been developed for the purposes of pricing and for bidding are in fact the specifications that we are exceeding or meeting, so that we can be profitable and produce product in an effective manner. So takt time, again, is one of those things people often struggle with. It's how we determine what the customer's demand rate is and it's used to systemize a pace of production to meet the customer's demand. And so here we have a formula that shows you how you would calculate TAC. So it's the effective work time per time period. So how much time do you have during the time frame to produce the product? And then the customer's demand per time frame. You then divide the 150 into the 450, and you come up with 3 minutes per unit. So the TAC time for that product is there needs to be a finished product coming off that production line every 3 minutes. And if your line does not allow you to meet that 3 minute rule, then you've got to be looking at added capacity or a different process to achieve the customer's requirements. Any questions on TAC time? Everybody understands what TAC time is then?
Yes.
Okay. So TAC time
Yes.
it's a pure measurement. It's all it is. We use it often to ensure that the product going through the production process will meet the expectations of the client. And if it changes over time or the customer's requirements change over time, it allows you to predict what you've got to do to meet their requirements. So if you have a customer who has been historically wanting 100 units an hour and your production line is producing 110 an hour, and then all of a sudden the customer comes along and says, I need 300 an hour, then you immediately know that your TAC time tells you that you're not going to meet that expectation, but it also helps you to calculate how much more production you need to be able to meet it. So that's where you'll see companies use this if they're running one shift. And let's say they're able to produce what the customer needs on one shift and they double the capacity, then that's why companies look at adding a second shift if they can, because that allows them to double throughput, and it means they use the machinery twice as effectively as they did previously. That's a more desirable solution in most cases than just adding a production line and using first shift, for example, and have two lines instead of one. Okay? And again, that's a decision that leadership in the company has to make as to whether they're going to invest money and add capacity or utilize the capacity in a different manner. When you're doing your future state maps for your product, these are just this slides here to have you something you can come back and look at later as you're drawing your future state. These are some icons that are standard in the industry that allow you to tell the story of your product, of your process, without having to put a lot of words on the paper. So if you're, for example, if you're talking about FIFO, then you can just put this symbol in your chart, and people know what that is, and it saves you having to write it out. But all of these are Kaizens, work in process, shared resources. These are just symbols that can make your charts a little less busy when you're trying to develop those. All right, so that future state has to look at things such as customers' demand phase, understanding the customer's demand for your services and your work, including quality characteristics and lead time. So when you draw that future state, one of the things you have to ensure is that what is your customer's demand, and will the changes you're making in that future state negatively impact the customer's design demand and the deliverables that are being done. So you might improve a process, but in the process slow it down. And so that's one of the things you have to weigh. Continuous flow process, implementing continuous flow so that the internal and external customers receive the right work units at the right time and in the right quantity. So the continuous flow simply makes sure that that you've taken all the wasted time out of the process, and that you're producing the product within specification or is within the time frame specified. Leveling phase distributes work evenly by volume, variety to reduce the queue time and allows small work units to remove if practical. So leveling just means you're leveling the process. You want to make sure that you don't have a subset of the process that is slowing the process down. It's very common in manufacturing operations. If you have a sub process that is a bottleneck, then often what we look at is whether or not we can duplicate that sub process to thereby increase the throughput so that we can keep the line running in an effective manner. Okay, the next few slides compare the current and future state maps. What differences can you see? What lean processes were incorporated in the future state? So here's the current state map, and unfortunately the ideal way to do this is where you can see both of them side by side. But this is the one we saw earlier with the welding, the stamping. They're stamping out metal parts, they're welding them here, and then they're adding an additional welded activity here. They then are assembling it into two separate assembly components, and then at the end the finished goods come off and it's shipped. So that's the current state. Here is the future state. So I'm going to give you a few seconds just to look at it and see if you can, if it makes sense to you. If not, I'll walk you through it. But what are some of the things you see they tried to do to fix it or to improve it?
They modified their welding assembly station. It looks like they added 2 additional welders. I'm not sure if that person in the corner is a manager or a welder, but the 3 people inside look like they're welders. So it looks like the product can move faster.
Okay. So if we look, if I do a little flashback, you've got stamping and 2 welders. And over here, we've got stamping and we have 1 welding. And what they've done is they've merged the welding and the assembly together into a work cell. So where before, whoops, went the wrong way. Before we had stamping, 2 weldings and 2 assembly for 5 stations. You now have a stamping station, and then it's being moved over into a welding station, which is doing all the welding and assembly at one place.
Yeah.
And so they've used a workstation to allow them to increase the tack time and improve the tack time. So all these elements of each and every phase have been dramatically improved. They've taken, pardon me. If you notice, we've got 1 day in between the stamping and the station here, where here we had a total of 10 days. Actually, more than that, it's 14 days. All this right here was replaced by 1 day. So by reshifting, pardon me, and we honestly can't tell by looking at this whether or not there's new equipment engaged, but what they've done is they've at least made work cells. And so where they had 166 seconds of value add time or up production time, and the process took 5 days in the new process. Before it was 184 seconds, but it had a 24-day time process. So they've not significantly increased, although they have, the value add. They've cut the value add time down by about 12 seconds, but they've taken 20 days out of the production lag. That means 20 days faster to their client, and it means 20 days less of inventory and carrying costs. for all that product. So the other things they've done here is before they were sending work orders, it appears, or work schedules to each station from central planning. Here what they're doing is they're providing the information at the beginning of the production schedule, and it's feeding through, and they're sending tickets to shipping for shipping purposes. And as the material comes in, they're telling production what's going into production, and they're basically tracking the raw material being set into batch and giving orders to shipping to ship. They've eliminated all of that daily production schedule input that was going to them. Let's see what else. Pretty much the supplier stayed the same, except it appears that here they were sending it as they got it, where here they're shipping daily. So whatever a day's worth of production they're sending down. Here they were just saying a full truckload down, and that could be days worth of production, which means you're also sitting on inventory. As it says here, they had 5 days worth of coils before production started. Now they're basically producing it as it comes in, and they're not carrying that 5 days worth of 5 days. Yeah, 5 days worth of inventory. So in this process, they've eliminated 20 days worth of queue time. They've taken their average time to customer from 25 days to 5 days. Their production time is about the same, a little bit better. And they're using a work cell assembly center doing all of the work in one station rather than having 5 separate stations. And they're doing it on 2 shifts. Let's see what they were doing over here. They were doing 2 shifts over here as well. Anyone say anything else that I missed? So this is the kind of analysis, while you might not see that radical an improvement in your process, this is the kind of thing you should be looking at from the standpoint of ways to drastically improve the process for your clients. Okay, we've covered that already. So this is just an example of from that example what they gained by the way they restructured that production line. So parts per minute was 25.9 hours of production time, and days 3.2 days. They moved to 5.3 hours, 0.7 days to fill those orders. So they had an 83% reduction in the number of touches that a product was done by the manufacturer, because it was all put into to one step and less handling. No increase in the workload for the value stream partners, such the supplier they cost the supplier nothing more to do this process. They had 78% reduction in process time, 25 days to 5, and 93% reduction in lead time for the client. So these type of statistical improvements, this would be what a type of table you would put together, by the way, for your current state, future state, to try and show your sponsor what your improvements have done. Now, in this case, these are the 5 indicators that were chosen for this example as far as the indicators that were used. Yours may be different. You may not have these same indicators, but there should be 4 to 5 measurements that you can make that reflect to your client, to your sponsor, what your process did for them and what the gains were. Will you see these kind of radical improvements? Probably not, but you should see improvements. Otherwise, you ask yourself why the project is taking place at all. The purpose of this is just simply to show you that by choosing the right indicators, you can track this kind of a comparison to be able to show the success of your project. And in your final presentation, that's what they're going to expect to see. Go ahead.
I have a question. So I know that with different processes, things could be slow due to the influx of the customer demand.
Right.
But would this take maybe 6 months or a year to notice some type of result?
In the case of this particular example, it would almost be instantaneous because once they reach. As a matter of fact, I ran a stamping and welding company a number of years ago in the 2001. I ran a stamping and assembly company, and we did something like this in a Kaizen. Now, it was what we did is we did a welding station like this using the equipment we already had on hand, and then what we did is we over time found a way to improve it better by purchasing automated equipment to get the work done. But realistically, if you were able to accomplish this radical a modification in a production process, you would see the returns almost immediately. Now,
okay, thank you.
If you're making minor changes, then yes, it could take 6 months or a year. This example was a rather radical one. This would have been overnight. You would have gone from, if this is the way you were last week, and you were taking 25 days, and you took a week to reassemble the plant to this configuration, the minute you start the lines up, you'd be down to 5 days.
Yeah, I was just thinking in regards to our BBP, for example, the overseas team.
Yes.
For the security manager,
yep.
We have some policies and stuff, and unforeseen events that happen.
Yep.
So I might see it as maybe a slower process than that quick
sure.
turnaround. Now in my field, which is supply chain, I would see this like the next week. If exactly. It was really improved.
Yeah, and it depends on what your process is. Especially if the one you've chosen for your BBP is a relatively minor process and you're not moving a lot of product or process through, then you're not going to see a radical financial change. You might see a substantial percentage change without necessarily showing a major dollar change.
Yeah, I see the percentage there, so that was really useful.
Yeah, okay. So a lot of times you want to measure things both in dollars and percentages, because sometimes it may not save a lot of money, but it might save a lot of time or a lot of labor, which is money. But especially when you're looking at a military environment where you have to force yourself to figure out how to capture cost as it relates to labor, because you already have the people there, and you're not going to lay them off. But there are some ways that we do that. You can still figure out what that person from a government pay standpoint costs, and especially if you're going to reuse them in some other capacity, then you can count that person, if they're eliminated from the process, you can count that as savings, even though you didn't lay the person off. So the current process involved a lot of touches and changes, and this picture right here is an example of what that chart you just saw, this process of taking us from this to this, was accomplished by the team using simple processes like you see here. And all this is literally trash bags that were cut and laid out, paper brown trash bags or brown paper that was taped to the walls. And up here, this is the process that was present at the time in the first stage, in the current state. And then they laid out down here, ultimately, the process that they went to as a final state. And they eliminated a lot of the complexity. Up here, you're seeing all those touches where they were moving those metal parts through every single one of those workstations, and product was sitting doing nothing. Well, down here, if you notice, there's very few touches. They eliminated all of this, and this represents the new process down here. This is all the inputs, but it basically, you can just by looking at if each of these pieces of paper represents a touch or a process step in the process, you can see how radically they improved the process. And they were able to map it out and design it using just sticky notes and brown paper. It didn't take anything fancy. Now, this is also what we often see people do in brainstorming, where they'll brainstorm and lay out the issues that currently looks, and then they'll try to figure out how they can, make the new process look to be more effective and to eliminate concern. Have any of you ever been involved in a brainstorming exercise where you use this, where you use sticky notes and this kind of a thought process?
Yes, in the past, I was part of a ASO 21 event, which is pretty much a process improvement, not exercise, but a project.
Mm-hmm.
And there was a black belt involved in this. He was a civilian looking at a military process,
right?
And it pretty much this covered like three-quarters of the room, and it took us through each stage of this whole project. It was amazing to see what people's inputs really, how much value it was to each step.
Good. So you found it productive then. It's a productive exercise, I mean.
Yes, because it took many months. So sometimes you have to go back to a stage and then see what the analysis was at that point. And it was that's why it was left up there, throughout the whole project until it was finalized. Yep. And we was able to pretty much recap on everything.
Right. And we often call, a lot of times in civilian work, they'll call this the war room, and they'll have this up on the wall, and it'll stay there for the entire project. And if something changes, you just move the sticky notes. And at the end of it, that's when you make it pretty and you do the charts like we just saw a moment ago. Anyone else? Well, if not, if you have an opportunity ever to do this type of a brainstorming exercise, I would encourage you strongly to try and participate in it. It can be very stimulating and eye-opening because what happens is you're in a room with people. They usually have various backgrounds and expertise, and they're throwing ideas out as fast as you can write them down on a piece of paper and stick them on the wall. And it can be very stimulating, and it usually causes people not to be playing their turfs because it's moving too quick for them to be sitting there trying to play politics with their responses. Okay.
Yeah, in my experience, what we saw was that at the end of the project, the right people wasn't included. Even though the process was implemented, the new change was implemented, the change failed because the right people weren't involved in this.
Well, so and that is cool.
Only supply people were involved in it, but it required actually, people that drive the vehicles and all that to be involved in it. So it had to be redone and reversed. It was a mess.
Well, that's a good point. When you're doing one of these exercises in the real world, you want to make sure that you've got the audience needs to be the people that are engaged in the process. So normally it's going to be supply people, it's going to be manufacturing, quality, leadership. Your sponsors normally going to be involved because you want them to have buy-in. And usually we use a black belt or a facilitator to run the exercise. But you're absolutely correct. If you don't have the right people in the room, then you don't get commitment for the change. You're talking about changing someone else's process, and you're not involving them in the discussion. And you need to get them to have buy-in. Okay. All right. Again, for some reason they put this in this early in the slides, but Bottom line is we have the discussion forums, and we all know that, so I'm not going to spend a lot of time on that. All right. These are the lean process metrics that we talked about earlier on. And in this week's team assignment, you're supposed to review those 14 lean metrics in that slide, the one that I just previously showed you. And these slides are in the classroom. Select those that are relevant to your BBP project and describe how each one applies. Where appropriate, provide actual measurements for the lean metrics for your process, such as lead time. Which lean metric is most important in the process improvement and why. So rarely will you not find 3 or 4 in this list that apply to a process. And so what they want you to do is pick the ones that make sense to your BBP, explain what the term means, how it could be applied in your process, and if you can, provide the actual numbers, such as the lead time or whatever, that pertains from your where you're at currently in the project. Include it, and then you're going to be doing that with a PowerPoint slide, with the title page and so forth. So make sure you follow this element of it as well. So that's your team assignment 3.1 for this week. And I wanted just to make sure you saw the slides right here in front of it. So those are the 14 lean process metrics that the problem is talking about. Okay, so in this particular factor, in the case of most of your projects, the type of things you're going to be looking at is you're going to be trying to address issues on how to save time, number of people, material, improve quality. In the primary objective of lean in a project is to improve the process flow. We're normally trying to either speed it up or make it less complicated. We map the future state and try to show where the organization is at currently, and then by applying lean principles and concepts, we then try to remove those elements of the process that do not add value and do not give the customer or the customer is not willing to pay for. So you're trying to eliminate waste by applying these lean concepts. Okay, I don't know what, okay. So one of the things I was going to show is at the end of these slides, there are about 6 more slides that provide some terminology that you may find useful in future courses, and in particular as you're looking at this process. So I just wanted you to see what they are. We've got continuous flow, supermarket systems, the Kaizen, the FIFO. These are terms that you'll see used in the literature. And I just want you to make sure you know that they're here in case you need a definition. Line balancing, work balance charts, standardized working, standard work contribution sheets, pitch, variable pitch boards, Hitchcock board boxes, runners and spiders. These are all terms that you're going to see in the reading, and you'll hear about in your future assignments in your career. And I just want you to know that on these extra slides back here at the back, you're going to see definitions that help you to understand the elements of what the words mean. Let's see, mapping, futures phase. So as you're trying to work on your future state, these slides are designed to help you to just think through the process before you just jump in and start trying to design it. You want to look at the customer's demand phase. Is the current process providing the throughput that the customers need, or do you need to improve it? You're going to want to see if you can determine what the tack time is, establish the pitch. You're going to want to determine how to meet the needs such as 5S and problem solving for the customer's expectations. And then when you move it on further, you're going to look for continuous flow phases. You're going to develop continuous flow points of view, so that chart showing how the work flows through the process. You want to look at the controls of the flow. What are the elements in each of the steps that add control to the process? Balancing the lines so that the throughput in each phase is consistent. You don't end up building inventory at different steps. Standardization of work and and then determining that the layout of the work area fits with the space that you've got available. And then the third is you're looking for the customers, reviewing the customer's demand through the tact time and pitch, review or create a full Kaizen, I'll get it yet, Kanban system, creating a load balancing process to make sure that the process flows in balance, and then creating a delivery and pickup system at the end that gets the product to the customer in the manner in which they want to receive it. So these are just some additional charts that you may find useful when you're trying to develop your future state. And I want to just run them through real quick in case you get bottlenecked and you want to look at these slides. They may help you design that. Okay. I went through those relatively quickly because I also wanted to, I've got the team homework from week 2 here. And so what I want to do is let each team just present to the class what their process value stream map look like. So I'm just looking to see if everyone's here. Aaron, I see you're here and Jake's here. I don't see Jennifer.
Yeah, Jennifer's on vacation this week. She
Okay.
said she's going to send you an email, but Jake and I can cover the.
All right. And this is just basically explain to the class, what you guys came up with and so forth. Okay. So we'll let you start and just take it away. And just, it's just off the cuff. I'm not grading on this. It's nice for everybody to see what the others have got going. And sometimes it helps you when you present it to see hiccups. So go right ahead.
Sure. Jake, you want to take this one or you want me to do it?
Yeah, I got it.
Okay.
So I'll be honest here. I was a little confused with what exactly you wanted, Mr. Ferguson, with the value stream map. I ended up going with this format versus the formats we saw in this lesson with the future, whatever term that was.
Well, that's future
but basically
state.
What we have, future state.
Yeah.
What we have here is we have all of our supplies, raw materials coming in. They initially go into the molding phase where they get cast molded into the shape that they need to be in. Then they get sanded. Then they get go through the bonding phase where everything that can be glued or melted to our passenger service units are combined in that process. Then they go through final assembly, which is essentially the core of our BBP. Then they move on to the quality check, packaging, and then shipping, and then finally on to the final customer.
Okay. And this is what you would probably call your current state?
Yes, sir.
Yeah, and that's what all the value stream really means is what is the process, which is your current state, and hopefully you're seeing the value being added to the raw material that ultimately becomes the finished good. And so what's interesting is this type of a process, some of the things that an outsider looking at this process, looking for ways to improve the process. I know you guys are looking at the assembly area, right?
Yes, sir.
Yeah.
Yes.
But for example, in today's quality world, people would look and see how much time this quality check phase is taking. And what they would look at is there a way to standardize these other 4 processes and have metrics that measure the performance within these 4 areas that would allow you to eliminate this check. So if your molded components, there were standards that ensured that those components came out of this shop exactly the way they needed, plus or minus the allowed tolerance, and so forth through each of the steps, then in theory, you ought to be able to eliminate a quality check. Now, if this quality check is computerized and it doesn't take a fraction of a second to do, then it's not a big deal. But if you're spending a good amount of time doing this, this is one of the things we try to eliminate in today's environment, is this kind of a step. And that's just
Okay.
that's just an observation. We should never be inspecting quality in. We should be controlling the process so you don't need to check quality. Okay, just an observation. And again, I'm not being judgmental. I'm just telling you that's one of the things you might ask yourself if it's your company, if it's where you work, is why do we do this?
No, that's an interesting thought. Definitely something
Yeah.
we can take into consideration.
Right, because if you can, and that's what we were talking about earlier today. We talked about coming up with metrics and standards and measurements. We don't do that just simply to keep the statistic people employed. If you can if you can do a Six Sigma quality deviation control process at each of these 4 steps, and the product coming out is within a Six Sigma quality variation, then you don't need to check quality because you're within tolerance. But again,
Yeah, that makes sense.
yeah, I know nothing about your product, so I could be talking in the wind. But I'm just telling you that this right here is always a bullseye for a consultant when they're looking at your business. Okay, good, nice. All right, then tell us about this slide.
Okay, I'll take it from here. So what we're looking at here is the waste table, and we've defined 4 waste categories. The first one being transport, and the description of that waste is the stagnated movement of parts between the assembly stations. And the impact of that we found is non-value added movements of parts that reduces the assembly times, or the times that assemblers could be producing the product. The second one is inventory. We've found that there's a poor location of certain inventory, certain items in the inventory in relation to the personnel in the assembly line. And the impact of that waste is the location of needed parts hinders the assembly line process, or the rest of the assembly line. The third one is the motion, and the identified waste has to do with the setup employees, the movement around the assembly area to prepare, retrieve, and deliver the supplies to the assembly line. And the impact of that waste is the waiting times are increased and possible line disruption, adding supply to the bins on the line. And then finally is the waiting, the last category. And there is the assemblers encounter wait times for replenishment or supply or resupply of their needed parts. And the impact is the wait time for needed components introduces downtime for the assembler.
Good. Yeah, so a lot of what you're finding is just non-value added time and movement around the plant. And we see that especially in older plants. And we saw it in my experiences in metal stamping and casting and injection molding. A lot of those plants were not laid out in the most effective manner. And for that reason, you a lot of times move product back and forth in the plant. And because of the nature of their business, their equipment is so large they can't just up and move it. It's where it is for certain reasons, heat and so forth. But yeah, it's not uncommon for this kind of a situation to exist. Good. Any comments or observations from the class? Okay, good job, guys.
No, it was pretty clear.
Yeah, good job.
All right, thank you.
Yeah, let's see what else we got here. All right, then let's see. Are any of I
will say.
All right, let me get it. Let me change the presentation so it's there you go. All right, take it away.
Okay, so for us, hold on. I'm trying to get the full screen.
Sure, don't take your time.
Give me 1 second. Okay. So here we have our value stream map. I'll explain it a little bit because I don't have like the line work like maybe other people. Like I was talking, a lot of us is in the military. There's a lot of policies and regulations that go along with this whole process, and we're trying to kind of decipher everything. So the first step is the unknown arrival. This is one of the biggest things that is affecting our in processing rate, because sometimes a member says a report no later than date, and it could be 12 April, and they might show up 8 April, or later. And then once that happens, once a member arrives, they have to sign into the gaining roster, which is now the unit. Now you belong from your old unit. Now you belong to this unit. So that takes 1 or 2 days to kind of for the system to recognize that. So at the bottom here we have the days of the average days of how much time this takes. And then after that, the in processing checklist is given. Then the member goes into various entities in no specific order. So what that means is that you have members of different ranks or different jobs, and they might get pulled to do something immediately when they get there due to maybe an on-demand unit or anything else, like they need that specific job to be filled like immediately. So this might take precedence over other priorities. And then once that happens, you get all that sorted out, the member comes back, and then the signature at various stops gets signed. So the checklist doesn't have only the security manager endorsement on there. You need to have multiple things, whether it's the unit deployment manager or the commander signature or the physical fitness monitor or anything like that. And then after that, the member reaches within 6 to 18 days, which you can see is a big gap in there. The member reaches the unit security manager, which is USM. There means unit security manager for processing. And once that happens, the security clearance eligibility is determined by the unit security manager. So what he does is he makes sure that you have the right clearance, whether it's secret, or top secret, or anything of that matter, to perform the duties you are to perform in that unit. If it's a top secret clearance, sometimes they're right at the edge of that 5-year mark where they need to be reinvestigated. Or if it's a secret clearance, they could be at that 11-year mark. So different clearances have different years. So the unit security manager needs to gauge their eligibility and then move forward with that process. So that takes a little bit. And then you have the unit security manager completes all training and documents required for the individual. So every unit has a different mission, has a different requirement. So the unit security manager needs to sit down with that member, especially if they're overseas, and go over some documents and training that needs to happen. Pretty much not a refresher, but it's a new base or a new unit, and different requirements call for different things. This is why policies and procedures, and even changing from one unit to the next, could change because of the mission requirements. And then after all this happens, the member turns in the check sheet to CSS. CSS means a commander support staff, and the commander support staff is pretty much a program that is ran by the commander. And the commander needs to know that you have completed all required items on that checklist to fully in process into the squadron. We have a 30-day mark here. We don't have we kind of put in at the bottom the future state because that's what our goal is. But right now the process is sitting at 60, maybe 45 days, depending on what the situation is with the member. Within this, we have the unregulated order, which is from giving the member the in-processing checklist, going through all these various entities, which is depending on what they come in as, what they have going on as far as family or mission or unit, and then to the time that the member actually stops into the security manager office and says, hey, I'm ready to be in process. So that's where we have the unregulated order. And then our 30-day timeline mandated by policy, which is by the squadron, saying this is what you need to be doing. It needs to be happening within 30 days or less. And at the bottom here, we have a couple X's because when we did the slide, we didn't have a current member that was in processing, so we couldn't track exactly the amount of days or time that it was taking the member. So I hope I kind of broke it down a little bit for you guys to understand, but if you guys have any questions, let me know.
Okay. Any questions on that? All right.
I got 2 minutes.
I have a few questions.
Go ahead.
Does anybody ever fail the security clearance?
That's where the security clearance eligibility happens. Sometimes a member might get to the unit and he might have a secret clearance, but for the duties that he has at that unit, he might require a top secret. Sometimes they do know that before they get to the squadron or before they get to the unit, but if not, then the process needs to start then, and that might take a while, which is where we're busting that suspense.
Yeah, I know. That's how it is there at Raytheon.
Raytheon, yeah, I know. Yeah, US, the DOD or US security clearances is a big delay. If the member doesn't have the exact clearance that they need, that's a whole reinvestigation, which is they still have a job, but they might not be able to get fully into what they need to do.
Okay. And I noticed that they complete our required training. How long does their training normally take?
Well, if they have the proper security clearance, it could take a day or two. It could take a week, depending on the availability of the unit security manager, which is another concern that we have, which is that we're very undermanned. So Calvin is over there in Germany, but if Calvin gets pulled for a deployment or different tasking, then that leaves the unit security manager at a hold until he comes back. So right now, we're facing big manning issues as far as fulfilling that duty. So the training might take 2 or 3 days, or it could take a month.
Okay.
Okay.
So yeah, so here we have the waste table. We definitely try to relate this to the line work, or try to put in that lingo. For transport, we don't have anything that relates to that as far as transportation, so we don't have anything coming into us. But as far as inventory, right now we have a huge binder with all these paper forms that we're trying to scan them into the system and make it a digital process. So the waste being discovered is ink and paper due to mandatory paperwork, and then it just causes resources that could be used somewhere else, but it has little impact on the customer. Movement, we don't have a one-stop shop. If we was to have a one-stop shop, meaning that every entity of that checklist is available in one office, and all the signatures were able to be acquired in that one office, we will have a one-stop shop in which the customer wouldn't have that delay within the time, because everybody will be available. Somebody will always be there to kind of sign off that checklist. And when somebody's not available where we're at right now, is that the appointments are additional appointments, and it needs to be required. So the movement of the customer, as soon as they get into the unit, to go through and check everything off on the checklist, we had a one-stop shop, it would be different. So not having that is requiring more appointments, which is delaying the process. The wait and delay is tied a little bit into that movement, unannounced or missed appointments. So if a person misses an appointment, then the training might be longer, or more forms have to be filled out as to why you didn't fill this out as soon as you got here or whatnot. And then that causes poor tracking, and is a waste as far as the customer's time, and then the supplier, which is the security manager or those that needs to sign that checklist. Overproduction is the information on paper. When you fill out the form, now you have to input it into a computer database. The reason that's implemented is because you need to make sure that all that information is accurate to put it into the data. You cannot put something in the database without verifying everything. So pretty much reworking that is causing that overproduction. which is the security manager doing double the work, reworking the paperwork if something is not valid, and then inputting into a computer or / digital database. Over processing is the continual redoing of planning and scheduling new arrivals. So meanwhile, you might be expecting a member, on this day, he might not show up to a week later, or maybe he could show up a week earlier. So now you have to make room for this person, or you have to pretty much put him on a new schedule or plan to get this person in process. You're over, it's over processing. You kind of just like, rescheduling, redoing, remaking that appointment. So pretty much time wasted due to internal processes, drawing the supplier away from the core responsibilities. So now if a member is scheduled to arrive next week, and then Calvin, which is the only security manager, has a bigger priority, now he has to rework that whole week's worth of appointments. So which is just causing a lot of rework. And then the defects we're having is the timeline of 45 days is busted. On average, it takes 60 days to fully in-process a member. Now, the policy is that we need to be under 45 days. So under 30 days, but the policy right now with the standard is 45 days and is being broken. According to, program and policies, we're not in compliance. So that's the impact, which always needs to be reported up to the commander as to why we're not meeting that, that compliance. And then people is pretty obvious, not enough manpower. There's no alternate manager. So if Calvin is not around, there's really nobody else to do the job. So, we're looking into that somebody needs to get hired or another person needs to be tasked with this additional duty. Security manager is not the primary duty of the active member. If it was a civilian, maybe he would be the primary focus because he would never move around. He would never deploy. He would never, go somewhere else. So having an alternate there would be a huge advantage. But there's poor continuity, and if the security manager deploys, like I mentioned earlier, or takes leave, there's no turnover, there's no coverage.
Okay. Any questions or comments? All right. Good job.
No, it was really thorough. Thank you. Yep.
All right. Our last team for this evening, Kim and Latoya. Want to take us through your process?
Okay, our process starts where the operator requests material from the MRO room is either through email or share. From there, the MRO personnel receives the order. They process the order and make sure that the order is in stock. If it's in stock, they inspect for expiration dates and make sure that the material is the material that the operator ordered. If it passes the inspection, well, if it doesn't pass those checks, it's discarded. But if it passes those checks, it moves to the SMT area. From there, the material, these arrows are gone wrong. They went wrong. So, yeah. I think this is the step for recertification. But anyway, if it passes inspection, it goes to the production floor. When it goes to the production floor, it's either stored in a freezer or a storage area where the material is stored for the operator to use. When the material is stored there, at the end of each month, there's another inspection to check the material that is expiring the following month, which is the final Friday inspection. If the material is expiring the next month, it is then discarded. If not, it's placed back into the storage area for later use. And that's the end of the process.
Okay, any questions from anyone? Okay, what about the waste table?
We start off with transport, and that's personnel having to deliver material from one building to another and from one area to another, which impacts time as well as money. And then the other one is incorrect packaging, which affects the effectivity of the material. So if the material isn't packaged correctly, then it could cause the quality of the material not to be effective, when that's an impact on the material as well as money. Inventory is unused material being discarded monthly. We have frozen MRO material that gets discarded on a monthly basis, and some of it is unused but could still be usable. So that affects money as well as material. On the movement, we have operators having to get up and get the material. It's not like right there in reach or readily available for and to them. So that impacts time and money. On the wait and delay is the amount of time that elapses once the material is ordered and when it's received. So that impacts time. Overproduction is having too much inventory on hand. That's where we have material that's stored that's not being used or is not going to be used, and that affects the money and space. Overprocessing is the implementation of the color dot system. We have a system set up where a certain color means that the material is going out on that month. So we may have like a blue dot means something is expiring in January. So anything with blue dots needs to be off the floor by the end of January. And that affects the people. And the use of the inventory log is, we have an inventory log that they have to sign in when they're getting products and material. But the thing about that is nobody uses the inventory log to track data or keep up with inventory of the material. So that's a waste. And then as far as defects, inadequate training and quality of material, meaning like sometimes we get material in that's not usable. Say for instance, it should be soft and it may come in hard. So that material can't be used. So that affects the product as well as the material and the customer, as well as money, because we wasted money on it and then the customer can't get the product on time. And defective product. Then the people is inventory not being managed, and that affects money and the material.
I have a question. So for the having too much material or too much inventory on hand, it seems like in your process, it's the material that it's not available right away, or it's not, like you said, wait and delay from the time the material is ordered to the time the material is received. So you might have, I'm guessing you have certain items, maybe shelf life items that are you have too much of, but then there's certain items that you don't. So where's the balance between what you need versus what you have too much of?
That's part of our project, is to figure out how to eliminate that, because what's going on is we may, like one area may have an excess amount of frozen material, and then another area may not have enough. So we're trying to get them to base the ordering on the workloads, which fluctuates. So it's not really a balance at this point in time.
Yeah, so there's not a person there to kind of that's in charge of the MRO process. It's just, people getting what they need and everybody just grabbing what they need and not using whatever. So
Yes, we've implemented. I'm sorry.
Oh, you good.
We've implemented where we have 2 MRO personnel that deal strictly with the MRO material. And now each area is getting star points, meaning they will be the one person that is contacted in regards to ordering material to help control the inventory in each area.
Okay. And then my last thing is there a way maybe that you could track like the projects that are coming in the next quarter, the next month, as far as what's needed, and then you could kind of foresee what you need for every single product or every single project that you have coming on, and like that you have like a little foreseeing of what am I going to need for the next quarter or the next month. Is that something that maybe you guys have thought about?
That's one
What do
of
you mean by
our
project?
I think he thinks that workload, based on our workload, and that's one of the suggestions that we've being suggestion that they go in and look at the workload that we're going to be doing, and you look at the materials that's needed for those programs and order the material by the workload instead of just ordering the material when they think we're running out.
Exactly. Sometimes I know with Raytheon, you guys produce parts for the Air Force. So, for example, if I have a contract that I need an X amount of circuit cards from Raytheon that's coming in March 2018, and I need it by 6 months later, fall of 2018, I'm gonna need this amount of circuit cards. I have this amount of workers, line workers. Each one's gonna need this much to do one circuit card or whatever the case is. Just kind of like a ballpark estimate of what you need.
Well, there are several programs that use the same types of materials, so it would be kind of hard to do it that way, and it's also based on the operators. Some operators know how to use just a little material, but there's operators that use more material than others, so it would be kind of hard to base it on that. But most of the time, that's how they like anticipate the work that we're getting, and they try to order based on that. But at the same time, I spoke to the MRO personnel man. He told me that he runs a spreadsheet, and when he thinks we're running low, that's when he'll place an order for more material instead of them just going to different areas, checking what they have in all of the materials within the facility before ordering. But that's one of our suggestions, that they start doing that.
Yeah, just taking an average or streamlining. Okay, if this took this guy this much, then maybe he needs some training or anything like that. So maybe streamlining or getting an average of what's needed for that contract or job or whatever it is. But
right.
Thanks.
Hello?
Yeah, I don't do it. I don't hear anything.
Me either.
Neither do I. Maybe he's muted himself and doesn't know.
Yeah, the screen's still on.
Can you hear me now? Can you hear me now?
Yes.
Yep.
Yes.
Yeah, I think my headset went into mute mode. Okay. Well, what I was saying was what I was saying, and I'll say again. You're all doing well. I believe you have a good handle on the concepts we've talked about so far in the first 3 weeks, and you're making good progress in the concepts as a whole. I would encourage you to look at this week and next week. We've got basically 2 this week and next week, and then we'll be into the final presentation for week 5. Everyone's doing well. I'm pleased with the progress of the class as a whole. I'll stay here in the event anyone has a question or comment they want to make to me personally. Otherwise, I've got everybody, and I'll mark you as here, and you're free to go for this evening, and I'll see you in class this week.
All right. Have a good night. Thank you.
Good night.
Good night. Thanks.